In this video, we're going to have a look at how to determine the general formula for a linear number pattern. In the previous video, we saw that a linear number pattern has a constant difference between consecutive terms. We also had a look at describing in words the method of getting from one term to the next for a specific pattern. When you are working with number patterns, it is very useful to be able to get a general rule or general pattern for that number pattern. This is because a general formula can then be used to determine the value of any number in that sequence. In any general formula, there are a variety of symbols used. N and Tn will be part of all of them. N indicates the position of a specific term, and Tn indicates the value of a specific term. The general formula for a linear number pattern is always in the form Tn is equal to Bn plus C. Next, we are going to have a look at how we will determine the constant values of B and C for a specific pattern. Example 1. Consider the row 8, 10, 12, 14 and give the next three terms in the sequence. Here we can see that you have to add 2 every time to get the next number. That means we have a constant difference between terms, which means this is a linear number pattern. To get the next term in the sequence, I will take 14 and add 2 again to get 16. And when I add 2 to 16, I will get 18. And adding 2 again will give me my next term of 20. Question B. Determine the general formula for the sequence. Another word for general formula is also general term or general rule. This formula will enable you to, using the position of a term, determine the value of any term. Because we keep adding another 2, we are going to add 2 in number of times. That is why the formula starts off saying 2 times n. If this is our general formula, we are implying that the sequence starts at 2 and from there we add 2 every time. And this is not perfectly correct. So now we need to determine what it is that we need to still add or subtract to get the actual values of our sequence. Here we still have to add 6 every time to go from 2 to 8, 4 to 10, and so forth, which means for our general formula we also still have to add 6, and this is now our final general formula. This shows that the B in the general formula will always be the constant difference that we have, and the C value is the adjustment that you need to make to get to the actual sequence. If you were to work one step backwards and determine the value of the term in front of the first one, it would also be 6. So you can also choose to determine the C value by calculating term 0. You can always test your general formula by calculating a specific value in the sequence. So I'm going to use the formula and determine term 3, which means the position, the n value is 3, and I'm going to take the formula and substitute n with 3. Then I'll have 6 plus 6, which is 12, and the third term does have a value of 12, and that means this formula is correct. Question C. Determine the value of the 20th term in the sequence. Here we are given the position of the term as 20, and that is our n, and we need to determine the value, which is t. So now I take my general formula, and in the place of n, I'm going to substitute the position of 20. So that means we have 40 plus 6, and this will give us the value of the 20th term as 46. Example 2. Consider the sequence, and the first question is to give the next two terms in the sequence. This time we have a constant difference of minus 12 from one term to the next. So to get the fifth term, I'm again going to subtract 12 to get to 77. And if I subtract 12 again, the next term will be 65. Question B. Determine the general rule for the sequence. For this, we will once again start off saying that Tn is the constant difference times n. So at the moment, the general formula says we are starting at minus 12 and then subtracting 12 every single time, which is not correct. To get to the correct values, we still need to add quite a big number, and that number is adding 137. This 137 will then also be our C value. Once again, you can remember to test your general rule, and I'm going to do that by determining the fourth term in the row. So I will change n to 4. This will give me the correct value of 89. Question C. Determine T9. Here we want to determine the value of the ninth term. So on the right, I'm also going to change the n to 9. This will give me a value for the ninth term of 29. Question D. Which term in the sequence will have a value of minus 43? This time the value of a specific term, or the Tn, is given. So when I substitute into my general formula, I will change Tn on the left-hand side to minus 43. Next, we can solve the equation to solve the value of n, and that will give us the position of this specific term. Firstly, I'm going to take the minus 12n and add it on the left-hand side, and then on the right we still have the 137, and I will also now add 43. Now we have 12n is equal to 180. And if I lastly divide both sides by 12, I will get an answer that n is the 15th term in this sequence. Now we know that the 15th term in this sequence will have a value of minus 43. You can also choose to do this question without algebra. If you continue expanding this sequence until you get to the value of minus 43, you will see that the 15th value is minus 43.